Nobody's doing 9. All right. So now that I know it's coming out of the board, it's perpendicular, is it not, sir?
Yes.
So can I ignore the cross product?
Yes.
All right, I'm going to ignore the cross product, except later on I'm going to figure out direction by using my fingers in another way. Okay, so then B, how big is my magnetic field? Oh, I don't know. Now we're going to enter Ampere's law. Ampere's law is integral of B dot ds equals mu naught I.
Okay, well, let's go straight to the...
So this is always going to be, because ds is the actual length, what shape are we going to draw is symmetric around a wire?
Square.
A square.
No,
A circle. Yes, a circle. That's what he meant to say. And so we're going to go BL, which is terrible, or BS, which is even better, mu naught I. Move the L to the other side. It's going to be B equals mu naught I over 2 pi r. Now, let's be real. It's always going to be a circle now. You don't have to remember 5 shapes. It's a wire. So one symmetric shape around a wire. It's always going to be the same thing. Okay? We're now talking about the current going through a circle. Right? As a wire comes through, it's just the current going through that spot right there. Okay? Everyone with me, sort of? Exactly. Exactly what Perel's doing there, right? You got current going through a circle.
I was talking to you about cylinders.
So, right? It's just a circle. So is the current going through it? Yeah, okay. All right. Got to devaluate it. All right, so B. So B equals mu naught is 7 pi times 10 to the 4 pi times 10 to the negative 7th. There we go. Woo! I, which is going to be in this case 10, because that's the one that's causing it, divided by 2 pi. Oh, look, that always cancels out. R, which is the distance between the two. How far apart are they, sir?
They are 0.2 meters.
0.2 meters away. So 0.2 down there. So I'm going to get 2 times 10 to the negative 7th times 10, which is going to be 2 times 10 to the negative 6th, divided by 0.2, which gives me 1 times 10 to the negative 5th. So my magnetic field, when I solve all this carnage, I get 1 times 10 to the negative 5th Teslas, caused by this wire at exactly where this wire is. Okay? So that's going to be 1 times 10 to the negative 5th. So my force per unit length is going to be equal to 15, or 1.5 times 10 to the negative 4th newtons per meter. That's the, yes, need a direction. I think it even says after direction, right? Oh, it doesn't say. Huh. We're going to do a direction anyways, because that's the kind of people we are. We are overachievers. So, well, you're an overachiever. Oh, look at your face like, oh, no. I don't want to hear that. All right. So, current's going down this wire. IL cross B, right? IL, B. B's out of the board. So I have to turn my hand over until I can curl my fingers in the direction of the magnetic field. Now I can do that, so I stick out my thumb. Which direction am I in? Towards the other wire. Okay, towards the other wire. Which tells me the force on the other one per unit length is 1.5 times negative 4 newtons per meters to the right as drawn, or towards the other wire. Currents that are traveling the same way pull together. Currents that are traveling opposite directions push apart. Just as a general rule. You don't have to memorize that. Just use this cute little right-hand rule crud. Yes?
The eye that he's affected by, that's the wire that's generating the field.
Right.
The eye that uses the other equation is the one on the affected.
Right, which makes sense. You need both eyes to have an equal opposite force, right? Okay? Right. Is that what you were looking for?
Yes.
Is that a good enough explanation? Okay, what's the next one I'm supposed to be doing?
13.
13. Oh, yeah, top, I didn't talk about that. Good. For an arrangement of parallel conductors described in exercise 12, did they say one? Calculate the magnitude and direction of the magnetic field at point P, located 5 centimeters to the left of current bearing I. Okay, so now I want to find the magnetic field there.
you just do this sum of the two magnetic fields.
Right. Just like electric fields, it's going to be a sum sort of situation, right? I'm just going to add them up or subtract them depending on which way they're operating.
Yeah.
No? Yes. Yes. Okay. All right. So that's good enough for our government work today. All right. So, again, same thing here. Coming out of the board still at this spot. Agreed?
Yes.
How do we figure out how much magnetic field? I'm going to go B times 2 pi r equals mu naught I. I go B equals 2 times 10 to the negative 7th.
That's B.
I'm just canceling also. Oh, B. Sorry. B equals 2 times 10 to the negative 7th. I is 10 over. Now, the distance is going to be 0.15 in this case. Right? Because it's 0.2 across. It's 0.5 here, 0.05 here. So this must be 0.15.
Yes.
Okay? So calculating this is not something I can immediately do in my head because I'm old. That's disappointing. What? 2 exponent negative 7. It's bad when your doctor starts calling you. Hey, you haven't been here a while. Hey, it's all right. I'm not dying yet. It's all right.
Yes.
They never used to call me, right? They used to say, hey, he's fine. Now they call you up and say, hey, dude, you need to come in. No, I'm good. So using the same reasoning, I got B equals 2 times 10 to the negative 7th times, in this case, 15 is the current for that one. All over the distance in this case is 0.05. Okay? So 2 exponent negative 7 times 15 divided by 0.05. 6.00 times 10 to the negative 5th. All right, you said what you think. How do you know?
You have to subtract them because that one's going out and the other one's going in.
Okay. So this current's going like this in this wire, right? So I use my thumb. It's coming out on this side, but it's going in there.
You did it again.
No. So it's going in there. So they are fighting each other, right? So this is the in the board, and that's the out of the board one. So this is technically the negative, although, again, it doesn't really matter, just as long as I keep track at the end of which one's bigger. Which one is bigger in this case? The one with more current that's closer, right? So 4.67 times 10 to the negative 5th Teslas, and the direction is into the paper, or negative Z.
So what's a solonoid?
That's my bad, yeah. That's my bad. I should have mentioned that before you got out the door, but I was rushing.
22. This is true. And then we
Okay,
can
but
solenoid.
I need to talk solenoids here first, because they're right. We need to talk about solenoids. Then I'll do 22.
does that also.
So let me do the solenoid one, and we'll talk about it. Okay. Then I'll let you do a couple of problems, and then we'll get to 22. I promise. I'm glad you're on it. All right. So, number one reason why people miss, there's one of the formulas said, which one of these is, one of the ways they tested the CFD diversity Biot-Savart law, they said, which one of these is Biot-Savart law? And labeled on the formula sheet is the following formula. So guess what a lot of people guessed? That's actually a useful law, so that's why we wouldn't use that. Oh, sorry, it's wrong. I'm missing my N. N. So it'd be mu naught Ni. Now, I was taught this formula completely differently, and so I have trouble with this formula. So we work on it. I focus. Fortunately, Ms. Manship reminded me I have to talk about this one today. This is the magnetic field caused by a solenoid in the middle of the solenoid. So in other words, what is a solenoid, first of all? Solenoid is a coil. And if I have a coil, the magnetic field is going to be the same for each turn. As each turn goes around, the current's going the same way. So each one is going to create a magnetic field in the same direction. Which add, the tighter you pack the coils, the bigger the magnetic field.
And that's like when we were using the terms before when we had to multiply by each square.
Right. Exact same idea. Okay. So if we're multiplying by each square, but if they're spread out, number of turns per length would reduce, right? And so it would actually reduce the magnetic field because they're farther apart. They're not helping each other as much. So the tighter packed they are, the stronger they are. Make sense?
That's just as a tile now, 1, 2, 3.
Right. Well, tightly means that there's no weird gaps. It has to be smooth in order for it to add in a nice way. Okay? So this formula is really straightforward. This is the magnetic field caused by a magnetic field caused by a solenoid. Solenoid. And a solenoid, by the way, is just a coil. That's all it is, metal coil. U naught is our friend, the magnetic coefficient free permeability of space thing. This I is current, so this is all looks just like Ampere's law, except for the N. And the N stands for the weirdest possible thing it could possibly stand for. It stands for number, which makes sense, of turns, which makes sense. This is the part that drives me crazy, per unit length. So there's a number of turns per unit length.
It's a lot harder.
Don't you like listening to the hammering, the loudness of my voice as I yell over top of it?
President, I found out how I came up with this thing answer, by the way. They basically did this thing called
All right. So on number 17, it says a closely wound solenoid of overall length of 0.25 meters has a magnetic field of 8 times 10 to the negative 5 Teslas due to the current I of 0.5 amps. How many turns of the wire are on the solenoid? Woofa. Remember, N is turns per unit length. They gave you a length of the solenoid.
4 pi times 10 to the negative 7.
Yeah, 4 pi times 10 to the negative 7 is your mu naught.
What's the exponent on the magnetic field of -3, -5?
Negative 7. Oh, wait, you mean mu naught?
I mean, on this
B.
magnetic
B
field.
equals 8 times 10 to the negative.
I got negative 5, it looks like to me. I'm going to go with negative 5 and feel good about it.
What did you get in the 32? Yeah, I assume you have to round to the nearest full term. Actually, probably not.
No, turns per unit length can be a decimal list.
Oh, then 31.8.
31.8 turns.
Yeah.
All right. Okay.
It's annoying because when you took 4 pi times 10 to the negative 7 from the calculator, it reads it not as 4 pi to the parentheses.
Ooh.
That's why you always do separate.
All right. 1, 3, 18, 9, 18.